Okay, so we have a limit here from a rational function. When we plug in -4, the top is 0. When we plug in -4, the bottom is 0. Typical situation for L'Hopital's rule. We copy the limit operator. We differentiate the top, 2x plus 1. We differentiate the denominator. This is no longer an indeterminate case. We just plug in -8 plus 1, -7. Finished. Another one, similar situation, but this time when we plug in or think we can plug in or imagine we plug in -infinity, these two become -infinity, both of them. These two terms are too small. At infinity, these are the terms that dictate. They are the biggest ones. So it's infinity over infinity or -infinity over -infinity. It's the same thing. L'Hopital's rule is applicable in this situation because the limit and a rational function and infinity over infinity. So we differentiate the top, 9x squared. We differentiate the denominator, 18x squared. We realize that this is again a L'Hopital's rule situation, infinity over infinity. We plug in again. And now we differentiate, we get 18x and 36x. We simplify the x. Now there is no need to do anything else. It's 18 over 36, which is 1/2. As x approaches -infinity, the function values approach 1/2, which means 1/2 is a horizontal asymptote at both ends. Then here we are looking for determining critical numbers, increasing, decreasing, intervals, and max-min, if they exist. So we differentiate the function, x to the third minus 40x. We start the table, always with a domain, and with the limits left and right of the function. So again, from these three terms, the first one is the most powerful one. It's in descending order, polynomial, degree 4. So as x approaches -infinity, the function will approach infinity at both ends. So now we try to find critical numbers. We said this, the derivative equal to 0. We divide by 8, we get this. We factor out x. And we know the degree is 3. We have to find 3 solutions. One solution is 0, and the other one, when we move 5 to the other side and take the square root, positive and negative the square root of 5. We also have to determine f of 0, which is 18, and I have to determine f of positive or negative the square root of 5. If you plug in the calculator, you'll get -32. The zeros have to exist in the table in the row for f prime. Do not leave this blank. You have to write 0 because that's what we got. F prime is 0 at -5, the square root of 5, the square root of negative the square root of 5, 0, and the square root of 5. And we have those numbers from plugging in the function. This is a typical situation for a local minimum or relative minimum. So this is a relative minimum because the derivative is negative and positive. This is a relative maximum because the derivative is positive and negative, and it's 0 in the middle or undefined. And again, negative, positive gives us a relative minimum. The intervals of decreasing are between -infinity and negative the square root of 5, and union. So f decreasing on a -infinity and negative the square root of 5 union 0 the square root of 5, and f is increasing on negative the square root of 5, 0, union the square root of 5, infinity. Notice that all these intervals have parentheses, no brackets. Okay, next question is the same. We found the derivative, we found the domain, no restrictions on this function. We started the table, we found the derivative, the top function prime 2x times the denominator minus the top times the denominator prime 2x. Always factor. I factored out 2x from these two terms, and I have x squared plus 1 and minus x squared. These two go away, so it's 2x over x squared plus 1 squared. A fraction is 0 only when the numerator is 0, so the only critical number is 0. We plug in the function, we get 0. And now we study the sign of the derivative, but this is always positive. So when x is negative, the derivative is negative. When x is positive, the derivative is positive. Decreasing on -infinity to 0, increasing on 0 to infinity. Typical situation for a relative minimum. And the limits are here. The limit as x approaches negative infinity, because I need to determine these either infinities or numbers. If there is a number, it's a horizontal asymptote. If there is infinity, there is no horizontal asymptote. Okay, so infinity over infinity again, 2x over, so then y equals 1 is the horizontal asymptote. And finally, we have a quadratic function. We are asked to find its maximum, and we are given the domain. In this case, I have to write 0 to 12. 0 to 12. And when x is 0, we have 98.6. And that's 6. Okay. And then when we differentiate the function, we get negative 0.2t plus 1.2. We set that equal to 0. We get 6 days. But it's no guarantee that this is a local or relative max. We have to put it in the table. And we have to study the sign. Easy, because this is a linear function with a negative slope. So it has to look like this, from positive to negative, or just plug in a number. When you plug in 0, you get a positive number for the derivative. And when you plug in any number beyond 6, you will get a negative. So this is typical for a relative maximum. Thank you.